Hey everyone, good morning, good afternoon, depending on where you are in the world. In England, it's just switched. We just got to the afternoon. It's just gone 12:01. So this is session AO. Stuart's going to be talking about pop-up mainframe. So I'm going to mute myself and switch my video off. Everybody who's joined is muted, although actually having a look at you, quite a few of you aren't muted. But I'm going to control things. If you switch your video on, I will switch it off just because we've had some issues with people, switching videos on and then, losing track of the fact they're on a conference and things. Ask questions in the chat. I'll monitor the chat. I'll throw questions over to Stuart as and when it makes sense. We've got about 10 minutes left for Q&A at the end. Go ahead, Stuart. Kick it off. Thank you.
Thanks very much, Joe. And thanks everybody for attending the session. I'm here today to talk to you about zero to mainframe CICD in a day, which may seem like a bit of a stretch, but we're going to go through and talk about exactly what the company I work for, Pop-Up Mainframe, provides that enables us to do this. And we have done this for various customers already. So Pop-Up Mainframe, we're all about empowering our customers to basically achieve more with the mainframe. We have a bunch of existing customers and partnerships. Basically, Pop-Up was spun out from Sandata, which is the parent company. For about 10 years, Sandata was doing mainframe consultancy, building up best practice ideas, building up a staff of very experienced resources. And about 18 months ago, that capability was removed from Sandata and turned into Pop-Up Mainframe. So it's basically evolved over a period of time, and we're now quite a mature, sort of slick, well-oiled machine. We do have partnership with various people, but one of our key partnerships is with Microsoft Azure. We do actually have a marketplace offering sorry, I'm just turning this off so it doesn't keep beeping at me. So we have an Azure marketplace offering that allows people to basically go into Azure and spin up a Pop-Up Mainframe instance within Azure. So it's a very sort of slick process. There's no sort of need for a discussion around it. You just basically log in and spin one of those things up for yourself. But we do also have very strong partnerships with BMC. And that's one of the key things we'll be talking about today. We have a BMC specific pop-up, which includes a number of CICD tools. That is what our CICD in a day offering is really all about. So a lot of people talk about mainframe like it's a legacy thing that we need to move away from. But that's not what the data actually proves out in reality. What we're seeing is that customers who've got an investment in the mainframe, they're typically seeing increased workloads. They're seeing a need to update their applications more frequently. They're seeing large shops say it would be extremely useful to be able to do all of this in a more sort of high velocity fashion, because the transaction load is increasing. Workload unpredictability is increasing. So anything that would help with an elastic kind of mainframe offering would be really, really useful. And what we see in reality is the mainframe is often the last piece in the automation journey. We see customers who've become quite adept at using DevOps tools on distributed applications, stack applications, but still the mainframe is a problematic offering. It's something that we see people constantly running up against sort of mainframe environment scarcity. So why is this? Why does this happen? Why is this so difficult? Well, often there's real resistance to change in these established mainframe environments. Often some of the staff are sort of nearing retirement. They're used to doing things a certain way. We potentially have some ingrained manual processes. we do have the dev test environment shortage, but balancing that against a sort of appetite for change often presents blockers. People do use things like IBM ZD&T or mainframe virtualization on the cloud, but the problem surfaces when you try and right size that environment. It's all very well spinning up a mainframe instance, but how do you make that mainframe look like your production environment? How do you get the data and the applications specific to a production-like environment onto the mainframe without ending up with something that's basically the same size as your production mainframe, i.e. terabytes of data, which is difficult to back up, snapshot, bookmark, etc. How do we get production data that's compliant with regulatory requirements? How do we mask sensitive data? How do we integrate tools into this process, and how do we maintain those tools? And how do we attract new talent into our mainframe development and testing teams when we're potentially presenting them with green screen environments that they're not particularly adept at using, they're not familiar with? So there's been a real push recently with things like Zoe, and also with the various BMC tooling offerings to enable customers to achieve the same results through Eclipse-like environments that they can plug tools into. And that's exactly what BMC Topaz offers. It's really a skinned Eclipse instance that allows you to integrate all the various tools that you would need in the CI/CD pipeline into a nice IDE that's very easy for people who are not perhaps skilled with 30 years of mainframe development experience. So we've spoken a bit about the snakes, the sort of resistance elements that make adopting DevOps on the mainframe really hard. What are some of the ladders? How can we actually make this process as streamlined as possible? What are the accelerators that we can use? Well, automation, speed and quality, and those two on the surface may sound like they're at odds with each other, but they're not, because automation, basically repetition or practice. And the more we practice anything, the better we can become at that task, and the more we can iron out the wrinkles and remove errors from the process. We can help remove some of the bureaucratic attitudes towards DevOps by sort of giving examples, demonstrating quick wins. We fail fast, we fix things, we actually embed our best practice into an automated process, which of course increases customer satisfaction, results to a shorter time to market, mitigates unplanned work. Unplanned work is a time sink. How do we reduce that? Well, we can reduce that by bringing in automation. Automated testing is a huge benefit there. If every time we build our code, we're testing it and only deploying code that passes our stringent test criteria, we can remove a huge amount of manual work right there. We remove idle time, increase productivity by bringing in tools to maximize productivity, and ultimately reduce costs. So there's a huge amount that's achievable. But how do we move from where we are now, potentially, where we do have some of these manual processes, to a more sort of automation-driven pipeline around DevOps? Well, DevOps is really just another item on the list of challenges, as far as we're concerned. And those challenges typically result in everything slowing right down. We can't achieve high velocity because there's just so much uncertainty and red tape and resistance to change. So what are we offering that actually allows us to break through some of this? So what we see in all of our customer engagements thus far is there's a real scarcity around environments for dev and test. So we typically have a number of teams that are looking to develop or test code, or perhaps try out new things, try an upgrade of specific ZOS capabilities, but they need to basically share resource on physical mainframe environments. That results in usually one team at a time having access to that environment, which of course is a huge bottleneck, which prevents innovation, slows down that velocity that we're looking for. So what we can do is, with a pop-up mainframe instance, is spin up an instance of the mainframe, right size it so it's got the right applications and data there to enable that particular project team to do their tasks, to do their development testing tasks, and then retire that pop-up mainframe instance quickly and easily. So you've got a much more elastic capability, which is not restricted by other people's need to access it. You can have an instance just for yourself. So what is a pop-up mainframe? What is this thing? Essentially, we're running the pop-up mainframe on a Linux instance. So it's IBM's ZD&T offering, tried and true, very dependable software that we've spun up on Red Hat Enterprise Linux typically. We can run it on Ubuntu as well. Most of our customers are quite happy with Red Hat Enterprise Linux, but we are building now an Ubuntu environment as well. And to all intents and purposes, the pop-up mainframe is effectively exactly the same, functionally speaking, as the physical mainframe that people are perhaps adept at using. So you can log in, use the same green screen environment, same tools, same third-party code is compatible. So to all intents and purposes, it's just another mainframe. There are some limitations around the license usage. You can't use ZD&T for production workloads, and you can't use it for performance testing. But aside from those things, anything goes effectively. So to recap, pop-up mainframe is effectively equivalent to a physical mainframe, but it includes additional things as well. So we've baked in all of our best practice, all the things we've learnt over multiple engagements through that 10 years of consulting with Sandata and the 18 months we've been a separate company. All of the best practice, all of the tools that we've developed to script and sort of ease the adoption of ZD&T, that's all baked in to the image that we make available to the it's typically a hypervisor image. That's what we bake the product into. So it's an OVA file, or it's essentially an image you can spin up on various sort of clouds. They tend to be a bit proprietary, but we build out the various OVA equivalents for all the big cloud offerings. And how is this different to ZD&T? The slide I showed previously is a video we created recently. One of my colleagues who's actually on the call, I believe, Bronwyn, she created this. It's a great video that just summarizes how pop-up mainframe is different to ZD&T, and that's available on our website. But effectively, what you're presented with when you configure ZD&T is some binary files that you need to download and configure yourself. Now that may sound trivial. It's not trivial. It's quite a big task in and of itself just to get a ZD&T instance up and running. So we provide a ZD&T instance fully configured and optimized with all the things we've learned over our decade plus of experience of working with the mainframe. And we also give you a bunch of tools on that and a services engagement to ensure success. So we always sell the pop-up mainframe with a services engagement to make sure our customers are up and running and they get value from the pop-up mainframe offering. We've also got various sort of utilities and tools baked in, including integrations with some of those business partners that I spoke about earlier. One of the big ones is Delphix. We have capability in there that allows the pop-up to seamlessly integrate with Delphix masking and data virtualization capabilities. We've also got automated DASD creation tools as well, to enable you to very quickly expand your pop-up to the right size as needed. And we have a mature migration process that helps us, again, to right size the pop-up so that when you do create a pop-up instance, you don't create this bloated thing that exactly resembles what you're running in production. What we want is a small, optimized pop-up instance that's made for your particular development or testing activities. And we keep it as small as possible so you can basically copy it, reuse it, and share it with your colleagues quickly and easily. So how do we explain what the BMC pop-up instance is? Well, effectively, it's a pop-up instance. It's Red Hat Enterprise Linux, typically running ZD&T, but we've also baked in all the BMC software tooling that we have an agreement to sell. So we have a subset of the BMC offerings, which I have a slide which I'll show in a bit more detail shortly. But effectively, we offer an integrated, ready-to-run turnkey solution, which provides a CI/CD pipeline based on the pop-up mainframe. So it's really an extrapolation of the pop-up mainframe that we've already spoken about. It's just got that end-to-end pipeline available with the BMC CompuWare tooling. So how do we right size a pop-up mainframe and make it look like the physical mainframe that we're perhaps using in pre-prod? Could be a test environment, could be any physical mainframe. Well, we use IBM's migration utility to basically help us interrogate and package up the applications and data that exist on that physical mainframe instance. We corral that data and application code into transport volumes and then move that across to the Linux hosted IBM ZD&T instance, decorral that data, and then you've effectively got something which works just as the physical mainframe does and is a subset of the data on the physical mainframe. And how we right size that for a particular task is to work with the customer to look at which applications and files are really necessary before we build out this migration activity. So the migration utility is IBM's product, but we've basically streamlined and optimized that, built some automation around it to enable us to move data across in a sort of very efficient manner. And we do that by, well, we've got a conveyor belt approach where we're basically building transport volumes. And while we're loading one of those transport volumes, we're basically transporting the data on another. So we have this kind of tag team activity where one sort of transport volume move process ends. We basically reuse the same transport to fill it back up with data. That enables us to move this as quickly and efficiently as possible. So to revisit the BMC pop-up, because that's really what we're talking about today. And I apologize if I've covered a lot of groundwork in order to get to this point, but there's quite a lot of understanding that needs to be built up in order to understand how we've kind of got this mainframe capability with BMC tools in the first place. So we have a subset of the BMC offerings that's available on our BMC pop-up. You can see there's a few gray boxes on here. We don't have all of the BMC tools available to us, but we do have the key ones that we've negotiated in order to package up and resell as this turnkey solution. Of course, this can be optimized for your particular needs. There are other tools that we could potentially bring in from BMC if you have a particular requirement. But this is the baseline sort of image that we start from, if you see what I mean. And so in terms of the Topaz environment, that is basically the backbone for all of these tools to integrate into, it's an Eclipse instance, which allows us to basically pull in different products, and those products work as perspectives in a familiar manner within the Eclipse environment. And this is really it's really useful for people who perhaps don't have decades of specific mainframe experience. For younger team members that are coming in, the ability to use something like Eclipse in order to analyze code, in order to build tests, in order to debug code. This is massively helpful and basically allows people to become productive regardless of their level of experience working on the mainframe. And in terms of what we end up with, we have an ability to basically spin up a pop-up mainframe instance. So all of the orange environments that we see on this slide are ultimately pop-up mainframe instances. The blue instances we see, the blue environments, are physical mainframes that we're integrating with on this sort of DevOps pipeline. So one of the key things we often hear from customers is they're already using certain tools within their production or physical instances. So for example, a lot of customers are using Endeavor, and the tools that we use, the ISPW tool that we have, which is effectively the equivalent of Endeavor from BMC, can interface directly with Endeavor. So we can use the Endeavor bridge that is available in order to synchronize any Git instance. That can be GitHub, Bitbucket, GitLab, whatever you're using. We can synchronize that with Endeavor and basically use that as a two-way communication bridge between Endeavor and our pop-up instances. So the whole idea with all of this is really to give you an environment that's ready to run, that's ready to receive your code and enable you to basically do some development and testing work quickly and easily. So it's really a cattle not sheep, cattle not pets rather, attitude. So what we're trying to do is basically provide you with something that you use for a given task, use it for that task, and then just bin it off afterwards. So we're not looking to replace physical mainframes. We're really looking to augment them in order to provide extra capacity to enable us to achieve that dev test velocity and get code in the hands of our customers more quickly and more reliably. So in terms of a use case scenario, how have we used this offering in order to allow our customers to achieve success in their various endeavors? Because a pop-up mainframe has relevance to really any development or testing activity. You know, people often talk about different approaches to mainframe modernization. Should we break bits of our application off and put them in the cloud? Should we run them through microservices instead of running them on the mainframe? Well, there's a journey to get from the start of that discussion to the destination, and typically that involves a huge amount of testing and building of confidence before we can realistically say, yes, that works the same way as it did on the mainframe, and it's just as reliable. So the pop-up instance that we offer allows you to test more frequently, more reliably in any of these mainframe modernization endeavors. So one of our customers had a requirement to look at IBM's ZOS Connect. They have a bunch of existing code, obviously on the mainframe, that's assessed or accessed at the moment through .NET library code, which basically is calling native routines on the mainframe through Kix and MQ. Now, the sales pitch for ZOS Connect is, well, we can help you do similar things, but using RESTful interfaces to commoditize those interfaces via sort of RESTful APIs that you can plug all sorts of different applications or devices into that don't have to have mainframe native interactivity. But knowing that that's going to work for your particular application and believing it's going to work are two different things. So how do you actually test this out? How do you go from being sort of semi-convinced that this is worth a proof of concept activity to actually making a decision that this is something that's going to provide real value to the business? Because there's a huge amount that's potentially going to be gained from using ZOS Connect. We can effectively we can reduce the cost per transaction by moving some of this activity effectively off the MIPS sort of counting mechanisms to sort of non-MIPS compute activity. This is IBM's own slide. This isn't me saying MIPS are a bad thing. This is IBM's own positioning. So what did we manage to achieve with this customer? Well, we did a ZOS Connect POC with zero risk to the business, very low friction, because effectively we were spinning up, yes, the existing code that was on the physical mainframe, took a copy of that, moved it across to the pop-up instance, which was the biggest sort of delay in the whole process, actually getting access to their code. We rewrote those calls, which we're using KICS and MQ interfaces, down to RESTful APIs that wrapped those things essentially on the mainframe. So we went from a 20-second delay through those legacy interfaces down to a 1-second round trip through the ZOS Connect interfaces. And that's just the first step in the process. So this is a big US, UK energy supplier. They've taken a close look at the viability of this and quite impressed with what they've seen so far. But the ZOS capability gives us options around various things. So, you know, we could effectively begin to look at a way to consolidate access to these critical business applications and make them available across a wider sort of gamut of interfaces and applications. So it's really just at the beginning phase, but the key thing I'm trying to convey here is we've made it possible to actually validate that this is of value to the business before the customer actually decided to go ahead and actually do this in reality, in anger, as it were. Another use case we have is Z16 support. So this is available through ZD&T 14. Might be difficult for a customer to actually spin up a ZD&T 14 based image. So of course, we've built one. We've built one within our labs. It's just going through final testing. But what this enables us to do is to give that to our customers, put that in the hands of our customers, and they can get early sort of visibility of whether or not the applications that they're currently running would work the same way on Z16. That's pretty much a given, I think. There shouldn't be too much risk there. But again, when we're dealing with critical enterprise business applications, we actually need to we need to demonstrate that we've covered all the bases, done all the relevant testing, and we are compliant with all of our regulatory bodies before we can move things on to updated instances. So that 20-mile-an-hour speed limit that we spoke about, which is basically a symptom of the lack of sort of confidence around doing things at velocity on the mainframe. We're providing the option with the pop-up of using safe, fast capability, which is very low risk to the business. It can be an isolated sandbox-based environment that is completely firewalled off from any of the physical mainframe instances, allowing us to try out new things, allowing us to hone a CI/CD process and build up a pipeline where we're basically delivering code at velocity without actually providing any risk to the business, or very minimal risk to the business. So that's kind of the bulk of my presentation here. I don't know if there are any questions at this phase. We do have a very brief demo, but I don't know if anybody has questions around any of this at this point.
Hey, Stuart, there's no questions posted yet. If anybody wants to post things in Zoom, and if anybody wants to post it in the Zoom chat, sorry, if anybody wants to be unmuted and have a little one-on-one voice chat, just again, post that into the meeting chat or post it privately to either Stuart or myself, Joe Winchester, and we can unmute you. Hey, Stuart, there's a question in the chat. I'll read it off to you. Is it free to use? Question mark. Sorry, I may have missed that part. So what about pricing? This question.
No, it's not free to use, unfortunately. So we can talk to individual customers about their specific use cases, but a base price for a pop-up mainframe instance is essentially $33,000 US. So that's the typical starting point. Obviously, everything nowadays is a discussion and a negotiation, but that's the starting point. Adding the BMC tooling to the pop-up instance effectively doubles the price. So we'd be looking at 66,000. But again, we view that as a real value-based offering. Doing this in a sort of quickly executed, very robust, sort of tried and tested manner is basically going to allow you to achieve so much more in a shorter period of time. And that's effectively why we're charging the money. You're paying for a decade plus's worth of intellectual sort of property and best practice.
Cool, Stuart, thanks for that answer. Rod, you posted something as well in the chat. Do you want to be unmuted? I'll unmute you anyway, Rod, just really quickly, if I can find out how to do that. Here we go.
Thanks, Joe. My comment was just that data is the problem for agile dev test environments. You know, even if you've got the time to spin something up and create it, it's maintaining it. You know, I see in customers. So the pop-up services to kind of identify what data is needed, migrate and move it and mask it, you know, most importantly in a repeatable way, it is the key to successful moves to agile development on mainframes, I think. What do you think, Stuart?
Oh, I agree wholeheartedly. Yeah, that's, I think, one of our biggest sort of IP elements that we offer, the ability to actually build small, sort of easily moved around, easily sort of replicated instances, because we do have a whole, I mean, we're quite limited today in terms of time, but we do have a whole process around best practice in order to build what we call gold copies or gold images, which are fully masked, fully compliant with regulations, which enable us to basically give our customers real surety that they're not doing anything that's going to get them in trouble with their regulators, because we mask everything within the production secure environment before we move it to any dev test environments. And again, building a sort of repeatable process around that, which is governed by code and quality gates, gives us the ability to do this stuff without taking a huge amount of time and without meeting resistance from the business. You know, once we've got these processes in place, it becomes very organic for various dev test people, team members, to basically access a pop-up instance through a self-service interface for a particular task, use that thing for their task, you know, move their code back into maybe a physical mainframe and actually retire that pop-up instance. And the great thing about this sort of workflow as well is it's working really synergistically with the way IBM's floating user license works for ZD&T. The whole cattle not pets attitude fits in really well with the floating user license, because as soon as you've finished your work and you've freed up the license, it goes back into a shared pool of licenses for somebody else to use. So you really do get to sweat the assets in terms of your ZD&T licenses.
Cool, thanks, Stuart. One really quick thing as well, just before, if you want to get to the demo, just in the interest of Sujit's question about pricing and being a sort of, vendor neutral conference, even though, vendors sponsor the conference and GSEs are always happy. If you do want to get access to a ZOS environment at zero cost, what I often tell folks, especially students and people wanting to learn, there's a free Google, it used to be called Master the Mainframe. It's now called IBM Z Explore or Z Explore. Google for that. And it's for students, but any early professional, you get access to a mainframe. You're very restricted on what you can do, but there's some education courses. That's a fun way to just get to really learn your way around the mainframe. And then there are other things as well. Stuart, I don't know if you want to talk to them now or later on, but we had a presentation earlier about WASI as a service. I don't know if you want to position that against that later. And there's also, I think there are other vendors in this space. I don't know. I don't want to knock you off balance, but I just...
yeah, I think there's undoubtedly a huge amount of competition in this space. The key thing, as Rod pointed out, is the ability to get the data.
Yeah. Mm-hmm.
Off the physical or pre-production mainframe, mask it, right size it, just bring the right amount onto a virtualized instance, whatever it happens to be, whether it's WASI or ZD&T running on x86. In order to do that's really the sort of the golden ticket. It's actually building something that looks like your real mainframes, because having a generic mainframe instance, yeah, it's a starting point, but bringing the data on and the applications is the harder piece.
Yeah, and Rod just posted in the chat as well. Again, there's something called IBM Z Trial. It's obviously very different. It's more about trying stuff. You're really talking about this, production, mirror subset. The pop-up mainframe is, and it's called IBM Z Trial. If anybody wants to check that out, I think you get 3 days. You can extend it anyway. Rod's posted the link in the chat. So thanks, Rod, very much for that. Anyway, Stuart, if you want to kick on with your demo, and thanks very much. I think you're good to go. Cheers.
Thanks. So this is something we pre-recorded. We do actually have Kartik on the call. Kartik's one of our dev leads within the pop-up mainframe team. So we can actually give you some more technical responses around this if there are questions of a technical nature. I'll just run this.
Hey, Stuart, really quickly.
Verified to be accepted.
Sorry, if you want to pause it.
Because the value needs to be a value.
Sorry, everybody's muted. Kartik, can you just stick your hand up or stick your thumb up or something so I can recognize you and unmute you? Because you're unmuted. Oh, got it. Great. Kartik, you should be unmuted now. Oh, excellent. So Kartik, you can participate in the discussions. Go ahead, Rod. Sorry. Sorry, go ahead, Stuart.
Thanks.
Okay, so we already have a pipeline defined within Jenkins, which we use to automate the deployment of new code drops. The first stage of this is to execute some tests to ensure that the code actually passes the test before we even consider deploying it. And we can see from the build output that we have an unstable build. Appears to be because the tests have failed. So let's dig in, have a look at what's happened. So looking at the test results within the Jenkins pipeline, we can see we've got a clear test failure, and we're given an indication of which test actually failed. So Topaz Workbench is an Eclipse-based tool. It allows us to pull in all sorts of different plugins into the Workbench product in order to allow us to jump around quickly and easily, to analyze code, do code coverage metrics, for example, program analysis. In this case, we're going to be going through to Topaz Total Test and running the test in order to actually understand a bit more about where the problem is arising. within our code. Now just click the run button and wait for this to execute. And we can see the test has failed, and we're seeing an exit code of 12, not verified to be accepted. And this is because the value needs to be a value less than 4. So obviously we're returning a value within our code which is unacceptable. So we'll have a look at that code within ISPW, another fully integrated product within the BMC CompuWare suite. And here we're looking at the code module where the error has occurred. And we can see we're returning a value of y, which is actually incorrect. That should be a value of OK. So we'll make the change, save the code, recompile the code and build it. And here we'll also build the second module, the COB Calc module. And now we've got successfully built code, we can go back to Topaz Total Test in order to just verify that the changes we've made have actually fixed the problem. And we can see within the total test perspective that execution success was achieved, meaning the code has been successfully changed to remove that bug. So now we can go back to our Jenkins build pipeline to verify that the end-to-end pipeline is functioning, that our tests are passing as we expect them to now, and that the automated deployment occurs exactly as expected. You can see we're currently through the process of running the tests, and we're now into deploying the code changes. It does take a little while to go through this. And we now see a successful test result. And if we go back into our Topaz workbench, we can actually see where the code was deployed as a result of that Jenkins pipeline execution. We'll just go back to ISPW, refresh the view, which does unfortunately require a login. But after that quick refresh, we can very clearly see the code has now been successfully deployed into the staging environment by the Jenkins pipeline.
That's the end of that demonstration. I don't know if there are any questions. I mean, it's probably stuff that you've all seen before. We're not really breaking the mold here in terms of showing the BMC tooling. The real upsell here is you get that all pre-configured, integrated and ready to run in an OVA file that you can download and install within a day. That's really what we're differentiating this offering as. We realize you've probably seen the BMC tools before or various other Eclipse capabilities. This is something that's really quite unique, we feel, because it's ready to run with all of our experience and sort of best practice capability, ready to run within a day. So any questions at this point? No? Okay. So just a bit more about the team members. We call ourselves pop stars. Effectively, we have a wide sort of range of people with various experience levels, but we've got an absolute sort of wealth of experience around DevOps and Linux within the team. Effectively, pop-up is all we do. That's what we do as a business. That's our one mission. We build environments on ZD&T and make them available to customers with as small amount of friction as possible. And although that sounds simple, that's something that, you know, we've got a wealth of experience behind, and we make it as quick and slick as possible. We did recently win an award, which is mentioned here, Technology Innovator of the Year. And again, these things are available on our website if you have an interest in finding out more about this. So in terms of the presentation, I'd like to thank everybody for your attendance. As I say, we have one mission and one product, and we're constantly evolving and codifying the lessons we've learned from our customer engagements back into the offering. So the more we work with customers, the more we learn about how to do this better, and the more that gets codified back into the product to ensure that we're meeting our customers' needs and evolving with them.
Hey, Stuart, that was phenomenal. I'll just kick the sessions off. We're getting some claps and things for you. One quick question. So if you were a customer and you wanted to approach Pop-Up Mainframe and get this great environment working, the hardware, do customers stand that up on their own private, Intel servers, or do they rent those from yourself? You provide it as a cloud service? How does that work?
So the offering works on any x86 architecture. So basically it can be on premises. It can be something that's run in the cloud. Basically we can run this wherever you can run a Linux on x86 effectively. We don't offer our own cloud hosting capability. We do have an offering on Azure. We have a marketplace offering on Azure. But we're very flexible and we can work with whichever preferred cloud hosting provider a customer would like to have this stood up on.
That's phenomenal. I wonder, can you share, I didn't know, can you share what you and the team are sort of planning to do in the future? What's your vision for where you're going to take this over the next year or three, without spilling the beans about anything that's going to get you in trouble with?
I think perhaps one of the key things we need to do in order to evolve this past the amount of customers we have right now is to do more in terms of building up best practice guidance, to do more around building up documentation around the offering, to basically provide this more as a cookie cutter thing, which does not require the level of services engagement time that we sometimes see from customers. Some customers are very quick and adept at using this and they're up and running on their own. Some customers need a lot of guidance from us. But the thing that really assists in that is documenting more of the process and providing more tools perhaps to allow people to do things in a more sort of self-service manner.
Cool. We've got a question. Hey, Gary, go ahead. I think I unmuted you.
Yeah, thank you. Yeah, so hi, it's Gary Thornhill, CEO of Pop-Up Mainframe. Just to add what Stuart's saying, so I where we sort of want to take the product is sort of building tools and utilities around Git so that ultimately clients can self-service their environment, so they can bring in various components from Git or other SCM tooling, then they can create their own environment, and that could be via self-service as well, via Delphix. Because what we can do, we can build these environments into DevOps tool chains in a very straightforward way. So you could say, well, I want applications A, B, and C. Then it would go and pull those components out, the application bits from maybe Kix, MQ, DB2, and then actually build that environment on demand. Currently at the moment, you build a gold copy, and you can work with those gold copies, and you can update them. So you can have a batch utility that then migrates more data and refreshes them. So that might be you might want to refresh on a month or on a daily basis if it's exchange rate information for a bank. But what we'd like to be able to do is, so a developer, they can come in, decide the components they want to test and put into a pop-up mainframe, and that can all be under the covers. You can use something like obviously scripting, it would and then pull it using Ansible and Terraform to provision that environment, and that could be on-prem or in the cloud. And that's one of the most powerful, I'd say, features of this product, is that we're doing demos to clients where we kick off an install from Windows in Azure, and once we kick that off with the OVA file, that's by the end of the meeting, you've got a mainframe you can log on and start running your commands and start migrating data. So if we can do that as well with the actual application components, then that would be full environment provisioning on demand. So we're not quite there yet, but we're investing into that part so we can have something for clients can just use off the shelf.
That's really exciting. So that's really kind of advanced toolchain DevOps. So you're moving into the space of infrastructure as code there, aren't you? I think, where people often think of Git as just being a source code manager for their application source code. But if you can actually get the configuration as code into Git as well, that becomes really tasty. Nice. That's cool.
Yeah, you might need to use something like Artifactory to define what those applications look like. That would obviously work in with Git and tools like Ansible and Terraform to actually do the provisioning. So there's once you get into the what do you use, there's lots of ways you can skin that cat. But we'd like to think that we can certainly have a solution around it that clients could use.
So I have another thing as well. I mean, we're switching into sort of advert for this, which is great because I'm super excited. One of the other things I always think of BMC as being an absolute, front runner, if not head of the pack in the monitoring space, right? You have some phenomenal monitoring products. Do you just give people an environment and stand off, or presumably if let's say somebody gives you an environment and they say, you know what, can you give a health check? Can you monitor this? Can you give us some recommendations for tuning and so forth? Do you step into that space with this, or is that a completely different arm of BMC's business?
Well, so you mean on the monitoring side? So I mean, on the pop-up, you can obviously got ZDNT on the cover, so you can install any third-party software. So the Tivoli software is available if you're licensed for it, or you can install any other third parties. So it is technology agnostic what you can put on there, and you can use whatever. But we've not, being completely honest, we've not done too much of the monitoring space with the solution yet. The solution is only 2 years old, so we haven't ventured that far. But you could.
Yep. Yeah, Gary, to add to it, BMC also has some kind of monitoring tools that we can install on ZOS. So, yep, we can install and maybe we can try that, Gary. Yep.
Yeah, my question was more now the fact you have this environment that you could provide some of your expertise and your sort of, muscle brain power to look at it and say, you know what, this isn't quite, this has some vulnerabilities in it that we've seen, or this could be optimized, things like that. Yeah.
Well, I mean, I think that's a key use case really, because you can mirror. The great thing about this technology is that you can mirror any production environment that you like and test anything against it to the PTF to the PTF level. So once you've got the pop-up mainframe in an organization, you can just use SMP or SMP to install whatever you need for your particular environment. So it's a great production fix environment. You would never run production workload on it, but you could mirror your production environment and do what you like. So that could maybe looking at really complex queries on large databases, you know, installing other fix packs for production level problems. So, and you could, you know, quite often when you're supporting, when you get funnies to replicate the actual issue in your production or a pre-production environment is very difficult, but this is the perfect vehicle for doing exactly that and fixing it, and obviously fixing your defects, which is the most expensive part of supporting anything in production.
Right, so customers can sort of just crash test it safely. They don't have to provision or they could do some penetration. They could try and attack it or give it to some friendly third party, you know, somebody else to attack it for them safely and write a report, things like that. Yeah.
Yes, yeah, so we've got a partnership with Veracode for exactly that. So you can clients can use Veracode or whatever for vulnerabilities and to check accesses. So that again is another use case that clients can do.
Nice. So, hey, Stuart, I'm just going to let you wrap up for the last minute or two. Have you got any closing comments?
No, I mean, obviously, I mean, we really welcome any inquiries. We find most of the customers we speak to, even if they don't perhaps end up purchasing the product from us, they have a good conversation with us and perhaps throw some ideas at us. And we can basically usually exchange something of value. So please do reach out. We'd be more than happy to talk more detail about all of this.
And then how do they reach out? There's presumably they can just Google for you, or there's a link in the chart deck, and the chart deck's in the agenda, right? Or
that's right. I'm going to upload that in a moment. It's not there just yet. But yes, contact me or use the website. There's links within the presentation deck to the website, and there's a way of reaching out to us from there. But yes, please send me an email. I'll be more than happy to set up a meeting and we can show this in more detail.
Cheers. Cracking job, Stuart. Thanks, everyone. I think the conference has 1 or 2 more sessions today. Yeah, cheers. Thanks for attending GSE, and thanks, Stuart, and your colleagues as well. Cracking presentation. Cheers, team. Bye.
Thanks, Joe.
Thank you. See you.